Hi, everybody. Great to have you all here today. My name's Ike. I'm the CEO and co-founder of eWorker. It's a pleasure to have you all here. I'm so glad that you've all signed up and shown your interest in DevOps. Our incredible host today is PJ Mertz from GitLab. He's the education evangelist at GitLab, and he'll be taking you through with this introduction into DevOps by GitLab. So I'm going to hand it over to PJ and let him take the floor. Thank you, PJ.
Perfect. Thank you, Ike. So yeah, like he said, my name is PJ. I'm going to be giving a presentation and there'll be time for questions afterward. I'm going to go ahead and share a link to a version of my presentation that should have almost all the same things in it. So if you're interested in the presentation or if you want to look over some things more, you can check out that link I just put in the chat. But for now, let me go ahead. I'm going to start my presentation. I'm going to share my screen and we are good to go. Can everyone see my screen okay?
Yes, I can see.
Perfect. Okay. So, like we said, I'm from GitLab. I'm specifically on the GitLab for Education team. And my name is PJ Metz. I'm an education evangelist. And education evangelist is a type of job that is under what's called developer relations. And developer relations, companies like Microsoft, like Jira, like Pulumi, all these companies that make tools for developers to use need people to teach developers how to use those tools or show them why those tools are important. So developer relations, they're kind of like a teacher slash developer slash learning and development person. And your job really is to show people what the tool that your company creates or the platform your company creates is capable of and why they might want to use it. Now, I'm an education evangelist, meaning specifically, I work with our education program, which mostly works with university students. And we're starting to branch out a little more into anyone who's learning. So anyone who wants to learn how to use GitLab, anybody who wants to become a better developer and learn more tools, those are my people. Those are the people I reach out to. So I make content that are for beginners, people who are just starting their developer journey. I live in Florida in the United States, specifically in Orlando, just kind of smack dab in the middle of the state. It's very hot here all the time. It's usually above 30 degrees Celsius for about like 6 months out of the year. So it's always warm here. I'm into poetry. I used to write poetry. I'm into music. I play drums. And I'm into education. I was actually a high school English teacher for 10 years before I came through to GitLab. So I love learning. I love people who are learning. And I love trying new things and learning them too. I like 1980s music, anything with synthesizers or the type of music that sounds like you'd hear in the background of like a laser Star Wars type battle. I'm really into that. And you can find me on Twitter and on Twitch and on GitLab. On Twitter, you can find me at Metzingaround if you want to follow me. And if you want to check me out on Twitch, I stream about once a week, usually working on some Python, which is the language I'm currently learning. So we always start this presentation when we're talking about DevOps, and we're going to learn what DevOps is today. We start with this quote from Mark Andreessen, who is the co-creator of the Netscape browser, which is a browser from back in the 1990s. And now he's in VC and he like funds people and he's a big name in tech. But he had this quote a while ago: software is eating the world. And it's not necessarily negative, even though it can sound a little bit negative at first. The idea is that software is now ever present in our society. We use software to communicate with each other. We use software to keep track of our lives. Everything in our lives is quickly becoming software oriented in the modern world. Even when we talk about, there's a company called Sweetgreen, and Sweetgreen is a salad company. They make salads. They're mostly in like really big cities right now. But the way that Sweetgreen differentiates themselves from other companies that make salads and lunch and stuff like that is that they have a really clean, good app that you can use to order food from. and you can customize your salad, and really, like, it just seems like, okay, so you can build your salad on there, like other restaurants do the same thing. But Sweetgreen went public recently, like I think 1 to 2 years ago, and they went public as a tech company. And they said, we're not just a salad restaurant, we are a tech company. And they said this because they developed their app and the software not just for users to order food, but for the whole process of running the company, distribution, sales, kind of every part of this company that is sort of engaged in this software, in this app. And they're looking to change like the production chain of the way food gets from farm to person eating it. And so they believe, more than they're a company that makes salads, that they're a company that makes tech, and just the end result is a salad in front of you. So this is true for almost every company. Major worldwide companies have to be able to make an app. It's no longer okay for worldwide companies like Target and like Walmart and like H Mart and all these companies that are worldwide, distributed all over the place. It's not enough for them to just have the store or whatever they sell or whatever they do. When you're talking about like Amazon, it's not enough for them to just get a whatever you've ordered from a warehouse to your home. It is important to have the tech behind it that makes it possible. And so every company needs developers. And when we say software is eating the world, we say that that's kind of a good thing, because developers have never been more in demand than they currently are. So when we talk about developers and when we're learning to develop things and we're learning to make things, there's a certain workflow you follow when you're starting at and writing code. If it's just me, and I started learning to code in 2020, and I did it sort of live on Twitch. I would log into a company called Codecademy, and I would learn C# and JavaScript. And while I was learning it from them and going through my lessons, I would turn on Twitch and live stream it, and people could watch me make mistakes and forget semicolons and misspell variables all the time. I misspelled a lot of variables. But when I was learning, I remember learning and being able to run a website from my laptop, and I could put, the port 300, and I could put that in my browser, and I could see the website because it was running on my local machine. If I wanted to actually share that with somebody else, I couldn't really do that. And there's an excitement in making your app run or making your web app go and seeing it presented in front of you and seeing it do what you intend it to do. But if I want to show anybody else, I can't send them the address. I have to host it somewhere. So when it's just me working on a project, I store the source code on my computer. I compile everything locally. I'm running things in a terminal, and I can debug right here in front of me because I see everything I'm coding on my computer. But the real world and the working world, it's not just one developer. It's teams. It's multiple people. And after the team develops something, they want to be able to show it to the world. And so for the world to see things, there's a different workflow. If it's just you, sure, you can store code however you want. When it's a team, other people are depending on you. And so we need to talk about systems of creating software. And we're going to talk about how DevOps fits into that later. So this is all about ways to create software. So there's two challenges when you're moving from it's just me, I wrote some code and ran it on my machine and it did what it's supposed to do. The first one is we want to collaborate with other people. We want to be able to share the code with folks, and we want them to be able to work on it with us and make us better. We tend to do better when we have other people around us who have the same ideals and other people who have the same goals and work. And we want to get better as developers, and we want other people to help us. So if we're going to collaborate, we need to find a way to get the local machine connected with other people. And we want to run our code somewhere so that everybody's able to see it. If it's a website, if it's a phone app, if it's a app on a computer, we want it somewhere where people can have access to it. And these are the two challenges when we're talking about coding on our own. And DevOps helps solve these problems. And we're going to talk about how that happens later. But first, we're going to go back into history a little bit. So the way that software is created, and this is 60s, it follows the same. Now, how you move from one piece to another is up to your team. But no matter what, these steps are going to happen. First one is ideation. You're brainstorming ideas. Your users have a problem. The people you want to use your app have a problem. Your app can solve it. The problem is people have a hard time finishing that last mile from public transportation to their house, right? You could take a bus, but it drops you off. It doesn't drop you off directly in front of your home. So that last mile becomes, okay, well, now in major cities all around the world, there are just scooters everywhere or little e-bikes, and you can just rent it. So now that whole mile, you can just take a scooter home. That is a issue that they saw a need for. They created an app that has a, you can sign up for a scooter, you can rent a scooter, and then you just leave it wherever. They solved a problem for users, and now worldwide, we're seeing these in major cities. There's multiple companies now that have these scooters that you can just rent. So that's the idea, right? My idea is to have scooters available for people to rent for like $1 an hour, and then they can get home in 5 minutes with a scooter as opposed to 17 minutes walking. Requirements. Well, what does it take to have a bunch of scooters all over the place? Will people download the app? What information do we need to collect from people? What do we need to make it possible to make the scooters run remotely through the app? How do we get people to sign up? So you come up with all these requirements. What do we need our app to do? What do we want our users to be able to do with our app? At this point, not a single bit of code has been written. You came up with an idea, you come up with some requirements, then you start designing it. Maybe you're going to write some code in the design section, but more likely you're going to be talking it out, planning, designing, saying what cloud service you're going to use, saying what infrastructure you're going to use for your code. What's it going to be built on? What languages are we going to need to make this work? Designing is all where you make the decisions about how you're going to fulfill the requirements from before. After design, as I accidentally go backwards, there we go. After design, you actually get into development. It's the fourth step of 7 steps when finally you're actually writing the code. So building the software using some kind of programming language, this is the development team doing that. After you develop it, after you create the app, you have to test it. You have to make sure it actually works. You cannot write code and just hand it to the user and say, I hope this works, good luck. So you have to test it. You have to test a variety of things about the code. Will it work on Android? Will it work on old versions of Android? Will it work on iPhone? What if the hardware on the phone is a little bit different? What if it's a hacked iPhone? What if it's the internet? Will it work on a smartphone using a web browser? All these questions have to get answered, and that's what testing is for. Finally, you deploy it. Put it on the cloud. Put it on Azure from Microsoft or Google Cloud Provider, or on AWS, or on Heroku, or on Linode. There's all these places where you can deploy your code to so it is running and living so people have access to it. And then finally, maintenance. Do you need to upgrade? Do you need to make a change to the code? Did it start running slowly? Why is it running slowly? No matter what software you're making, all of these are going to happen in the process of creating software. Now, what process are you going to use in order to get through all of these life cycles? Well, the old way was called waterfall, and waterfall was based on what's called the assembly line, which is the most common way that humans have been producing goods since the mid-1800s. If you're thinking about assembly line, think of it like building a car or like building a house. You have to do one thing first, and when that's done, now you can move on to the next step. First, 6 people assemble a frame of a car, and then it moves along a line to the next person. Okay, now we're putting the engine inside the car and connecting all those parts. Next, we have another team whose job it is to put the tires on. Next, we have a team to put the metal on, and so on and so forth. It's not one person building a whole car. The car just kind of moves along, and different teams of people, or robots more likely now, put specific things on it as it moves along. And when one team is done, it's time for the next team, and then it's time for the next team. You just pass it from one group along to another. This was the way humans were making stuff for a long time. So when software came around, it was, well, okay, this team came up with an idea and they hand it off to requirements. And requirements says, well, this is the idea we got. What requirements do we need to make this happen? And then requirements goes, okay, we did it. They move it on to design. Design says, okay, this is what we think it should look like. This is how we think it should function. This is what we think it should do. Design hands it to developers, and developers make it happen. And so on and so forth. You just kind of hand it off to the next person. It's your turn. Enjoy, yada, yada, yada. So as you're going through all of that, it takes a lot of time. The design team can't do anything until requirements is done. The coders who are going to build this can't do anything until the design has finished their job. So you're waiting for the previous team to finish their work before you can start yours. So the waterfall method is a little slow. It takes a long time. And if you look at software, especially early personal software from the 1980s and 1990s, releases, when you finally deployed, which back in the day was literally mailing floppy disks to houses or to businesses, or eventually mailing CDs to people so they could have your programs. In those days, it was a slow process. You couldn't get everything until it was finally literally hand delivered to you in a package. As time moves on, we end up with a system called Agile. And Agile is a method of development that starts to combine a little bit of the work between teams. So instead of saying, well, we've got, the ideas people and the design people and the requirements people and the developers, Agile said, what if we made teams of teams and we start having some collaboration? Maybe the design people and the developers work together at the exact same time and trade ideas back and forth. So Agile starts kind of breaking down these walls that exist between different teams. It encourages collaboration. It encourages a lot of open transparency about what a team is doing and how they're creating something. We see Agile become the new way to build software somewhere around the 1990s, early 2000s. And it was working great. And Agile isn't a methodology, and it's not a set of tools. You don't go out and buy your Agile tools and bring them in and start using them. It's about having certain values as a company and then adhering to those values. We value the input of our users. And so we talk to our users about what they want out of our products. As a user, I want to be able to, and then you say what the user wants to be able to do, and then you can solve for that. And developers are in on it from the beginning. Well, that's great that you have this idea, but here's what it's going to look like to implement it. And so there's more open communication. From Agile, we end up with the people making the app and the people maintaining the app. There's still this separation between those two. And traditionally, the developers on one side are writing features. They're trying to deliver software as fast as they can. They're like, we just upgraded this, it runs faster. We just fixed this, that security issue is no longer a problem. And they just want to be fast with it. Developers want to make change quickly. Operators or operations, they're concerned with making sure that the service is stable. That if suddenly 2 million people find out about the app and log on, that it doesn't crash. They're worried about the security. They want to make sure that bad actors and hackers aren't able to get into the program and steal users' data. And they're worried about reliability, that 99% uptime. Very, very important. Is your app always reliable? Does it do what it's supposed to do? What's breaking? Why is it breaking? How do we keep it from breaking? This was traditional DevOps, and there's a wall between them. Developers finish writing code. They hand it to operators and they say, make this run. It works on my machine. You need to make it run on the internet for everyone else. So this wall is not very beneficial. So what we look to create is DevOps, which combines the two ideas. The people writing the code and the people maintaining the code need to have a way to communicate with each other. The same way that Agile broke the waterfall model and made it more collaborative, DevOps seeks to make it even more collaborative and even more efficient. So while developers are writing code, designing, and creating, operators are maintaining, securing, and defending. And when we marry the two of those, we end up with this. DevOps, getting software to people, is one job. It is not two different jobs. It is one job that people have different functions within. This cycle is connected. It's interlooped. It's not a waterfall. It doesn't go down and then it's done. And then you start a new thing. You are constantly working with your app and trying to make sure it's the best app that it can be. So when we talk about DevOps, we talk about certain stages. A stage in DevOps are in these words within the infinity symbol here. Planning is ideation and requirements. Creating is the design and development. Verify is making sure it works, the testing. Package and release is going to be deploying it somewhere. Configure and monitor is watching to make sure that the app works. And then notice that plan is connected from the operations side and the developer side because they need to communicate with each other. Abida, I noticed you have your hand up. You want to ask a question? And you can feel free to put it in the chat if you like. Okay. Remember, if you have a question, throw it in the chat. You can use the Zoom raise your hand function, whatever you need. No problem. Happens to me all the time. I'm always raising my hands in meetings. So when we're talking about this, instead of the separation between the two, now we've got them working collaboratively. And the idea is it helps us move software faster to people. So when we're talking about DevOps, here's how it works. DevOps is all about people. It's about culture, and it's about changing the way that you work with those people. DevOps is not about what tool are you using. It's all about making things move faster. So GitLab has come up with, looking at the history of DevOps, there are 4 sort of phases of DevOps that have happened. The first one is called BYO DevOps, bring your own DevOps. And basically you end up with, 14 different tool sets that you use in order to make your DevOps cycle work. So when we're talking about DevOps, we're talking about the way that teams work together and making it more efficient. And we're talking about things like Git. We're talking about things like issues and ticket tracking. We're talking about things like security. We're talking about all these things that need to be done to make software work. And we're trying to make it as interconnected as possible. So at the very beginning of DevOps, people had, say, GitHub, people had Jira, people had Travis CI, and all these different these different tools that they were just kind of using to do its function, and then that was it. An individual team at a company might say, oh, I'm using these 5 tools, and another team at the same company might be like, oh, well, we're using these 4 tools, and that can create some friction between those 2 teams. So when you're talking about, well, what are we using to test? One team prefers this for testing, another team prefers another one for testing, and each team gets to decide what works best for them, which is great. However, when we ask those teams to collaborate and work together, we start to see some issues if they're using different tools, and that creates friction among people, and that's not good. You have uncoordinated purchasing. So if you're a company looking for DevOps solutions, you've got 4 teams buying 4 different tools. That can be problematic because now not only are you spending more money, but there's 4 different ways of doing things, and that's kind of problematic and difficult. It's no consistency among the teams. There's no alignment among teams, and things start to silo again. Teams work in their own area, and then other people work in their own area, and there's no collaboration. Eventually, we end up with best-in-class DevOps. Over time, people realize there are certain tools that were working better than others, and they say, okay, well, look, all of our developers are now using this tool. All of our ops are now using this tool. We're all using this. And then it's what we decided, it's like, okay, we have less cost now because we've decided this is the one that everyone's using. We're all together on this. And Dom, I saw your question. I'm going to find a way to make sure that you guys can have access to this. It might just be that I put it in Drive or I send y'all a PDF. So if SlideShare is not working, I'll make sure to get you something. Thank you for that. Now, when we've got this, there's still a problem where one tool doesn't communicate well with another tool. Maybe you've got GitHub and Jira, and there's not a way to connect the two yet. So you have to sort of take things that you have in one file, in one app, in one program. You have to find a way to incorporate it into another. If you've got a totally different tool for security than you have for writing code, than you have for tracking what's going on, than you have for planning your projects, it gets complicated. So learning these tools is great, and having best in class was great, but it was hard to connect them. That takes us to phase 3, which is DIY. And this is where people called DevOps engineers created scripts and apps and methods that could connect your tools together. That connection and that skill set of being able to connect all these apps so they work together is extremely, extremely valuable. And that's why DevOps engineers are paid really well. Their job is to make sure everything works together really well, and people start connecting these different tools together. So it's customized. Every company started having DevOps engineers that was making custom integrations from one tool to another. Maybe you're managing your Git in one program and your issues in another. Well, a DevOps engineer came in and made like a little bridge between them, essentially. Oh, I've got some script. It's going to automate the movement of the code from one tool to another. Just run the script and it automates it. And it does it in the right way, in a way that's readable, and it's awesome. But it's still custom integrations and custom maintenance. And then sometimes you can worry about security and testing at the very, very end. And then that's something that's hard to deal with, because if you're testing and you're finding all these bugs, these are things that probably could have been prevented earlier. That takes us to the final phase of DevOps, which is called the DevOps platform. And that's what GitLab offers. As a company, we are one place that has all the tools you need to run a successful DevOps instance in your company. And so we offer that to people. It is faster cycle times. You've got everything in one place. You no longer have to switch between apps. One location, everything you need to make a good app using DevOps. So let's talk about what a typical flow will look like when you're making an app. And we're going to talk about source control, and we're going to talk about Git. All of this is focused on Git source control. So Git is a way of having a centralized repository that stores the code. So you can have developers all over the world, and they all have access to the central repository. What they do is they essentially make a copy of that code, bring it onto their local machine. They make a change on lines 50 through 56. So they make their changes, whatever it is they needed to change. They save it on their machine, and Git allows you to then what's called push back into the central repository. And now the central repository has the changes that that developer made. It's a super save, essentially. So let's say you're working on your local computer, you wrote some Python code, you love it, it's great. You save the file on your computer, and then your computer turns blue and explodes and you lose it. That's terrible. We don't want to be losing machines out here. If you have your code stored in a Git repository, you didn't lose anything. Your code still exists elsewhere. So you find a way, you get a new laptop. This one promises it won't explode, it won't die. And you open it up, you go to your repository, you pull it onto your machine, and there's all that code that you wrote. You didn't lose anything. When I was in college in around 2003, I had a friend who was a computer science major, and he was working on a project, and his whole project was stored on a single flash drive. And in 2003, flash drives were like very new. It was a whole new idea. It only held like 1 gig. It was a big deal. He ended up losing the flash drive, just gone, it disappeared. This was in, I want to say it was March. The end of the school year was the end of April. So we had a month and a half to figure out how to recover all of that lost stuff. He had a few files that were on his actual computer's hard drive, but he ended up having to remake a lot of it on his own. If he had been using Git, which at the time, I'm pretty sure Git didn't exist. If he were using source control, it all would have been saved in the cloud somewhere else where he could have just re-downloaded it when he needed to. So a couple benefits. It's like a super save, and it allows you to collaborate more easily because multiple people take it, they make their changes, they know who's making what changes. Hey, you're working on the authorization. You're working on the store on the website. You're working on the design of the website on this page and this page. And all these different developers have different things they're doing. And when they make their changes, they can all push it in. And if they only changed, if none of them change the same thing, then it just shows up in the central repository automatically. So if we're looking at GitLab and the way that we do working with a team and the way that we collaborate and use DevOps, the main branch is the official branch of code that gets deployed to a website, right? It looks at main, it sees what the code is, you've deployed it to a website, it runs, you've got a website out there, now people can go to it. But if you want to change something in main, if you change it in main, it changes on the website. So what you do is you make what's called a branch, and you do that by creating an issue and creating a merge request. If you're familiar with GitHub, GitHub has what's called pull requests. We call them merge requests because the end hope is that you're going to merge it back into the same branch eventually. So what you do is you create your merge request. You've now got this separate branch. This is where you start making changes to the code, and you commit those changes specifically to you make these changes and commit them to that branch. So there's main, and let's say you make a new branch where you're trying to create a new feature. You want to add a checkout to people, right? So they can check out from your store. So you make this new branch and you do all the work over here. You're making slight changes, some changes, and then you use what's called CI, which is continuous integration. And the CI allows you to test your code. You want to make sure it works. And so you run a couple tests on it, okay? You review the app. You make sure that the app works. You're checking it out. You're running a test version of it. You're making sure the website works and everything. You're discussing it within the issue that you've created. People are commenting. People are saying, this design doesn't look too good. Can we change that? Yep, we're going to shrink this thing. We're going to make the button go over here. Whatever design changes you're making, you do it all on this branch. Eventually, somebody approves the changes, usually a manager, usually someone important. You merge it, and when you merge it, the CD runs. So you might hear the term CI/CD. CI/CD is automating certain things. CD is continuous deployment, and that automatically pushes your code when it notices that it's back on the main branch. You can write a file and code that automatically pushes your code to that new place. Then finally, in here, you're monitoring your app. You're making sure it's running efficiently. You're making sure it's doing what it's supposed to do. This is the way it looks when you're working with a team. So what we have is that same infinity symbol from before. Problems come in, you work on them, eventually you get solutions. The whole thing is managed within GitLab, all of it, and it's all done with a group of project managers and like people managers and front-end developers and back-end developers and web engineers, and tons of different people work together to make this product work. This is overwhelming. This is a list of all the different tools that automatically come with GitLab. When you are using GitLab, this is what you get. So up top, these are the stages of the DevOps lifecycle. Remember, we talked about it was ideation, it was design, and that software lifecycle. We have turned those into very specific stages. Management is what's happening the entire time. The idea of breaking things into groups, and I'm going to show you a lot of all of this later. The idea of getting reports about what's working and what's not. Planning is creating issues. It's creating epics. It's creating roadmaps so you know what to do next. Create is actually writing the code. That's the Git management. Those are wikis. Those are static site editors. You can make static websites with GitLab. Verifying that things are working. This is testing. Packaging, that's deployment. Securing, making sure that everything is correct. We've got secret detection. If you enable secret detection, GitLab can help you keep from accidentally publishing AWS keys, API keys, anything like that that you need in order to access stuff. This is what you need here is secure. You want secret detection. Actually releasing the continuous delivery, GitLab pages, which is the static site thing that you can have. You can have static pages hosted on GitLab. You can configure everything. That's Kubernetes. That's a little beyond my ability. I'm not really good at Kubernetes. Infrastructure as code. You can monitor your app and make sure everything is running. You can have on-call schedule management, meaning if you've got people, site reliability engineers whose job it is to respond to GitLab is throwing 500 errors or GitLab has seen some slowdown on these issues. On-call schedule management means the people whose job it is to go and respond to security incidents or to problems, you can manage that within GitLab. And then finally, protecting against outside influences. All of these tools are things that are available inside of GitLab. So this is what GitLab actually looks like. And this is sort of my favorite part. I like showing this off. This is what you're looking at when you're looking at a GitLab project. What I'm going to do is I'm going to take y'all to my personal GitLab, and I'm going to show y'all what I do. I make a bunch of Twitter bots. That's kind of my thing that I like to develop and do. I'm writing them in Node, and I'm working on learning on writing them in Python. So those are my two languages I'm mostly using. Daniel, to your question, any compute services with GitLab platform or it's integrated with cloud service provider? If you can use GitLab on any cloud that you want, but the CI/CD tool is like inside of GitLab. It runs on GitLab's what are called runners. And a runner is written in Golang, and it reads a YAML file and makes stuff happen. But as far as which cloud service provider it goes to, it's up to you. But our CI/CD runs on GitLab directly, so you don't have to attach your CI/CD to like another. You don't have to attach the CI/CD to a cloud to run. You do have to attach it to a cloud provider if you want it to be hosted somewhere or deployed somewhere, if that makes sense. All right, so like I said, these are my Diva bots. I have several Twitter bots based on musical artists. And this is my project for it. You can see right here, it tells you that I've committed 103 times to this. I currently have 2 branches, and it tells you how big it is. This tells you what language it's written in. The yellow is JavaScript, and then there's a little bit of Python in here because I did put one Python bot in here, but it doesn't work yet. So if I was working on a team and someone was like, hey, I really need to change some code. I've noticed that your bot is not deploying on the right day. So let's go to my Shania Twain bot. So this is a singer. She was really popular in the 90s and 2000s, Shania Twain. And this section of code right here creates a date and time for the tweet to function. So let's say someone's like, hey, we're not getting any engagement from it. I want to change 12, which is the hour. I want to change that to like 2. So it's at 2 in the morning. You can do that directly in GitLab with a web IDE. And I can click this button. Or I learned this the other day, I can click the period on my keyboard, and it automatically opens the web IDE. Now, this is something like VS Code or Atom. This is a text editor that you can use in order to change code. So let's say we don't want 12 anymore. We want it at 2 in the afternoon. So that's going to be 14 is the hour now. I make a change. I can commit it right here, and I can make a merge request directly here from GitLab. I didn't have to download my code. I didn't have to go anywhere to do it. If I want to work locally, I can. I can pull it onto my machine. I can run it locally. That's fine. But GitLab also lets you do it right here inside the browser. And that's with the Web IDE. I'm actually not going to make that change, but I do want to show you. It's not just the Web IDE. We have something called Gitpod. And Gitpod is a separate company that GitLab and Gitpod work together, and Gitpod is integrated with GitLab. And if you used VS Code to write code, Gitpod is a VS Code instance directly in your browser. It looks exactly like VS Code. And I think it's pretty cool. So all of my files, all of my code, everything that I was just looking at on GitLab is now right here. So there's that code. It's the same code. Zoom in a little. And if I want to make changes to other files, I can. If I want to check my configurations, I've got those files there. Let's say I want to add, another job here. Like maybe this is my personal bot for like my personal Twitter page. It shouts at Mountain Dew every day, begging them to sponsor me with free soda. Let's say I want to make a change to this. Let's say I don't want it to be every day. Let's say I want it to be every Monday. I can add something here. Rule.day equals Monday. I can add that there if I want. So what's happening here is I'm making changes to the code, and I can commit them, and I can change the code, and then it will run. When we're looking at GitLab and what it has for us, one of the things it has are issues. And this is how you can collaborate with other people. So let's say I need to like add new bot, and it's going to be countdown to the World Cup. I want to make a bot that counts down how many days until the World Cup final. And I'll fix my spelling real quick. And that's down, not done. And I could create this issue, and I could tag people in it. I'm assigning it to me. I can assign it to my manager. I can be like, hey, I want to make this happen. I can add a label to it. I can create this issue, and what it does is it tells other people of what I want to get done. I'm not going to tag my boss in it real quick because I don't want her to be like, okay, so make the bot if you want. But so now we've got this issue. I said, here's the thing I want to do. I want it to do this, and then we could say, okay, what language should we use? And I can make that comment here, and then other people could come in and comment on that. Python is great, but it's new to me. And this is weird because I'm just having a conversation with myself. To show you, I'm going to give you all a link. This video that I'm going to throw in the chat is an example of me and my boss, and I only sent it to Ike. Sorry, hold on. Everyone in meeting. This video is me and my boss working through a fake issue with one of my bots, and it shows the collaboration as we bounce back from one to the other person in order to fix an issue. So that shows you a little walkthrough of GitLab as well. To show you the CI/CD, CI/CD in GitLab is written in YAML, which is a markup language. And in order to deploy to, I host my Twitter bots on Heroku. I wrote this, and down here is where the scripts run. And this is something I got directly from an article that taught me how to use GitLab mixed with Heroku so that I could learn how to actually deploy to Heroku. So I have a couple environment variables here indicated by the $sign in front of them. And I'll zoom in a bit. So these variables, it says, hey, this is my provider, it's Heroku. This is the app. I name the app here in a variable, and then the API key lets Heroku know that I have actual access to Heroku. So those variables are stored in GitLab. I go to CI/CD. I go to my variables, and I can see these are the variables I created inside GitLab. So when that YAML file runs, the runner looks for the variables here, and that keeps it safe. Because, you know, I could absolutely, instead of having a variable here, I could just type in the API key here, but this is a public project. Then everyone would have my API key, and then everyone could push code to my Heroku, and then I'd be in a lot of trouble, because what if they're distributing viruses to people? What if they're doing something malicious? What if they're tweeting propaganda or something? Like, what if they're going to use my Heroku for whatever they want? What if it's Bitcoin mining and it's like it's collecting a lot of prize, right? So it's important to like have that security, and that's just one of the security features that comes inside of GitLab. So this CI/CD automatically runs when the main branch is updated, and that's something that I use. And this is just for like a very kind of like simple project. Like, it's really just like there's 6 or 7 Twitter bots in here, and it just runs, you know. So that's an example just of like what it looks like inside of GitLab. You've got your project information, you've got your repo, you've got your CI/CD file inside of the repo, and all of this kind of automatically runs when you're working on it. This is the profile page, much like GitHub. If you've seen GitHub, this is contributions that have been made. This is my personal one. You can see actually for my work profile, I do a lot more work on GitLab than my personal one. Up here, we have issues that I'm working with other people. Let's see if we can confident. There we go. That's fine. So these are issues that people have tagged me in that I'm working on for work. You can see these labels. Hey, this is for the education program. This is for Twitch. You can see this is for community relations, which is the team I'm on. I get a to-do list. If I'm tagged in something, I automatically get it on a to-do list. So it's organized for me. We have things called groups. Let's go to community relations group. So the community relations group is the team I'm under. Here's the education program. Inside the education program, we have tons of issues. And all these issues live inside the education program, and it allows us to do work together. And it allows us to connect with each other, and it allows us to make efficient our work. At GitLab, we also have Slack, we have email, but we don't use email to communicate with each other. We use Slack for quick messages, and we use issues for bigger work. So that allows us to collaborate more easily and work on things with each other in a way that's much more effective. Now, my team, we don't really write code for our job. Our job is to help other developers be able to write code faster. But if we're looking at like the methodology and why we work the way we do, it's because it's faster. Because if we've got an issue here, like I think I have one, two. Actually, let me go to my personal one. If I go into an issue here, and I've got this add a new bot right here. If I'm like, all right, listen, I'm ready to do it, I can create a merge request right here. What we're going to do is we're going to assign it to me. We're going to make this new merge request, and we're going to create it. So it created a new branch right here for add new bot countdown to World Cup. I now have a new branch on here. And what I can do is I can open that in Gitpod, and I can start writing the new bot right here. This is how we go from issue, this is what we want to create, to branching it. Now we're working on just this feature on this branch. And then even that branch can have other branches that come off of it. Eventually you merge them all, and you've got whatever it is that you were trying to create right there. So I can create a new file in Divas Live. I can call it newbot.js. I'm in new bot here. I can import whatever I need to, and I can just start writing code, right? When it's done, I use source control. I add it here, make a message, new file added. I commit it. I sync the changes. And all I've done is add a new blank file here. If I go back and I go to Divas Live, here's the main branch. Here's that one I just made. So the one I just had was called new bot. Does not exist on main. That file's not here. But if I switch my branch here, there's new bot. And this way, because like I said in my CI/CD, I've got that function inside of here that says when main is updated, push it live, make it available to everybody in the world. This way I'm working on a feature until I know it's ready, then I merge it, then it's available for the world. So as far as GitLab, the company, we were started in 2011 as an open source project. We are still open core, meaning anyone can contribute to GitLab's code base. If you're really good at Ruby on Rails, we've got front end issues right now where people can contribute and help build our front end. Open source is a great way to get lots of experience. We've got that. So we're about 10 years old. We're coming on 11 years old soon. We incorporated in 2014. We have 30 million plus registered users, and that's paid and free. You can get GitLab for free. You just don't get access to all of the tools, but you do get access to a repository, a place to store your code. And if you verify with a credit card, because we had a lot of people using our pipelines to mine cryptocurrency, which was like really bogging down our servers. If you verify with a credit card, you can use our CI/CD, but you can create your own runners and written in Go, and then you don't have to worry about CI/CD minutes, and you don't have to like verify with a credit card. We've got education programs, open source programs, enterprise programs, and we had 2,500 community contributors. We're averaging about 120 community contributors a month right now. Lots of organizations are using GitLab, and this idea, like Goldman Sachs and UBS and T-Mobile and Ticketmaster and all these big companies use GitLab to build their projects. These are our values: collaboration, results, efficiency, diversity, iteration, and transparency. Iteration especially is a hard one to learn. It's make the smallest possible change you can and ship it. And that way you're constantly shipping new, like we have hundreds of updates to our code base a day that go live every day. Website changes, information changes, constantly changing. If the change is better, ship it. There's no reason to hold on to it. And transparency, we're public by default. We have a handbook that is 2,000 pages long, and you can learn about everything at the company. I mean, everything. Like if you want to learn about how like our SREs work, you can see how they're onboarded. You can see exactly what would happen if you're hired as an SRE. You can see what cloud providers you need to have. It's everything in this handbook. It's huge. GitLab Handbook is a great resource for people who are looking to learn more. Daniel, your question about coding experience to be a DevOps engineer. If you want to be, and I did it again, I sent it just to Ike. Sorry about that. That's for everyone. If you want to be a DevOps engineer, a person who helps implement DevOps at a company and make those connections, yeah, you need some coding experience. A lot of DevOps engineers write code to connect apps and programs and stuff. So a DevOps engineer specifically does need coding experience, the same as most developers would. If you wanted to do like program management, things like that, there are careers at GitLab that don't require a coding background, but engineering most certainly is going to require a certain amount of coding experience. But yeah, so this handbook you can look through. You can even find my job and see what my job is about and what my job is necessary for and what I do on a day-to-day basis, you can find everything. It's huge. You can find out about our product. You can find about what product does. You can, it's huge, 2,000 web pages long, but a great resource. This is our education team. It's myself and Dr. Hupy. She's the manager of education programs, and I'm just the education evangelist. That's really it for today. I would love to answer some questions. I know that I talked for 54 minutes when I'm looking at my thing there. I'll also share some other resources with y'all. Here's another video of me doing what's called a GitLab Learn project. And I'm going to find a way to share my presentation with y'all too.
I know for CI/CD, there's Jenkins, you have Travis CI, you have a number of them, Apache, Gump, a number of them. So it's quite, should I say, it's quite a revealing experience to me to learn of GitLab and what it can do. It's can use it to store your code. It can be a code repository. You can use it to build your CI/CD pipelines. But how different is GitLab from these other CI/CD tools? I know that you mentioned that it has a lot more features. It's just surprising to me that when you are mentioning or stating or calling out CI/CD tools, GitLab is not often mentioned. Thank you.
Often with GitLab, you're purchasing it because you want the single place for everything. So if you get GitLab for a company, or if you're using GitLab, you're using it because it's everything all at the same time. Travis CI and Circle CI, which are great products, they only do CI/CD. And you have to have your code repository elsewhere, and you have to have your project management elsewhere, and you have to have all these things kind of elsewhere, as it were. So with GitLab, it's like it's all in one place, so it's easier to have that one thing. It is harder to say, all right, we're gonna use GitLab only for its CI/CD, because it can be expensive. If you're only using GitLab for its CI/CD, a better option for your company would be to either look into using more tools within GitLab, or find a way to reduce your costs, because you wouldn't use GitLab for just CI/CD is kind of what I think my answer is. But it is good CI/CD, and you can actually find people talking about liking GitLab CI/CD out there. But if you say, what's my CI/CD solution? I use GitHub, then you're already using GitHub and you're looking to add a CI/CD solution. You look into GitHub Actions if it works for you, Travis CI, Circle CI, JFrog, whatever you're going to use, fine. But if you want to use GitLab, you're going to be using multiple tools. You would never use it for just one tool, I would think. Does that make sense? Is that a good answer?
Yes, please. Thank you.
Perfect. I saw Gabriel. I work as a data analyst. Recently started learning CI/CD for a project. What tips do you have for a beginner? The best thing for someone who's just starting with CI/CD is to just do like little projects. Like even if it's just running a script that says like echo, even if you're just saying, okay, I want to run a script, just echo this variable. And then you run it and you can see the logs and see what happens and see what's going on. So start small and just learn one thing at a time. Don't worry about, well, by the end of this, I better be an expert in CI/CD. I'm not an expert in CI/CD. That YAML file that I showed you, that's about the best I can do right now, personally speaking. There are people who are great at CI/CD. But as far as learning CI/CD, I'm going to send you our docs. And we also have, there are some classes that are available, but they're like self-led. So I'm going to send you the docs on our CI/CD. And using the docs is a great way to continue to learn and continue to just try new things. Additionally, there's tons of articles on like Medium and Dev.to, but it's usually for like specific things. This is the article that I used when I wrote my CI/CD file to deploy to Heroku. So if you say want to use AWS or GCP or whatever you want to use, just type like GitLab CI/CD or just whatever CI/CD you want to use, CI/CD and whatever cloud provider you want to use, and you'll find answers out there based on that. I hope that helps, Gabriel. Anjali, if what you know as a DevOps is GitLab, how do you scout for jobs? So do you mean how do we at GitLab look for jobs, or how do I look for a job like for myself if I want to do it?
Yeah, so what I meant was if, for example, the tools you know are GitLab related, and perhaps a certification, maybe an associate certification with GitLab, for example, and then you're looking for a DevOps job, entry level or so, how do you go about that?
So what ends up happening for a lot of people who are learning DevOps is you learn a certain set of tools, and if you know how to do DevOps with GitLab, you probably know how to do DevOps with other tools as well. It just becomes knowing the difference between GitLab and those other tools. It's very similar to learning languages. My first language I learned was C#. After I learned C#, I learned JavaScript. And JavaScript was way easier to learn because I already knew concepts and ideas from C#. Now I'm working on Python, and Python makes even more sense to me because I already knew these other things. So if you know how to use one set of tools, the other tools are similar enough that it'll be a shorter learning curve. So if your only experience is GitLab, and someone's like, oh, well, we don't use GitLab, we use GitHub and Jenkins, and we mix it with some Travis CI, and we've got Snyk and Splunk, you can still say, I'm confident I can learn those. And you can go ahead and say, I'll start learning those right now, so you can understand how you would change what you already know. So with a lot of jobs, it's less, do you know exactly what we need you to know? And it's more, can you learn what we need you to learn? Because every job is different. So they want to know that you can learn what they need you to learn rather than I already know. And especially like you said, it's entry level. Entry level is all about proving that you can learn and you know sort of a basic amount and that you can learn new things. I hope that helps.
Does that also work for Kubernetes related positions?
It depends on what you're looking to do with Kubernetes. A lot of times with Kubernetes, it's Kubernetes is getting into like the more complicated side of being a developer that I'm familiar with. But when you know Kubernetes, you know Kubernetes. Whatever tool you're using to manage it is one thing. If you can do K8s, you can do K8s, if that makes sense.
Yes. So what I was asking is GitLab easy to deploy to Kubernetes?
Mm-hmm. I'm going to send you our
companies
docs.
that are not using GitLab, they have cloud-based or even their own kubectl.
You are breaking up a little bit in your question. I'm having a hard time hearing the whole question. I'm sorry.
So, sorry, it's my internet connection.
So,
right. Okay, thank you though.
Yeah, what I just sent you is about connecting Kubernetes clusters with GitLab, and there's also an about page for it as well, Kubernetes GitLab. And I'll send you that as well. Sometimes there's just all the information is usually out there. It just can be kind of hard to find it sometimes. So I'm happy to like throw some of that to you. And then Daniel, as far as your question, when we talk about DevOps, I want to make sure I clarify DevOps is a way for everyone in a company to work a certain way. So you can learn DevOps as it's almost like a theory or like a style of work. DevOps engineer is a position, but learning how to work within DevOps and to understand DevOps, sort of like the way DevOps works, you can do that as a front-end engineer. So you can be a front-end engineer. You can be like, oh, I'm familiar with DevOps because I've used GitLab. Or, oh, I want to be a back-end engineer, or I want to be full stack, or I want to, whatever you want to do. Learning DevOps is more how you work, as opposed to like, you don't have to be a DevOps engineer in order to work with DevOps. It's kind of like a style of work, if that makes sense. Yes, perfect. Thank you, Daniel. That's it's a culture, right? It's a way of doing work. So it's a developer culture. So you can say, oh, I've done some DevOps work, even if you're a front-end engineer, because it's the culture of the way you work. Perfect. Any last questions? If you find you have a question later, or you want to ask me something, you can find me on Twitter. It's at Metzing Around. You can find me there. Give me a follow. Mostly I tweet about stupid stuff, but every once in a while I am talking about DevOps and GitLab and education. So, but yeah, Ike, that's it. I'm good, and I hope everyone else is happy. I'm glad you were all able to make it. I'm sorry about the confusion earlier about like which room you were going to come in and stuff like that. But I hope this was beneficial, and I really appreciate you all coming here. And I hope I'll see y'all online soon.
Okay, PJ, thank you so much for that. And thank you everybody for joining. We appreciate your time. As PJ mentioned, we'll send you some emails with so many resources that you can follow up with. So just stay in touch, follow us on Twitter, and we'll keep connecting and sharing great stuff like this with you. Thank you so much.
Have a great day, y'all. Thank you.